you know which is the first metal-based anti-cancer drug? Well, diamine chloroplatinum 2 is the first metal-based anti-cancer drug. It has been proved that only the cis form of diamine dichloroplatinum 2 has anti-cancer properties. Despite having the same molecular formula, transplatin does not show the anti-cancer property. This is because the property of a compound is related to its structure, not to its molecular formula. Meaning, not only the molecular formula but also the structural formula is also required to identify a compound completely. In this video, you will learn more about such phenomena. The phenomena of existence of two or more compounds with the same chemical formula, however, different arrangement of atoms is called isomerism, and such compounds are said to be isomers. Broadly, isomerism is classified as structural isomerism and stereoisomerism. Next, let us consider the various types of structural isomerism. Linkage isomerism, solvate isomerism, ionization isomerism and coordination isomerism are the possible structural isomerism for coordination compounds. We may start our discussion with linkage isomerism. Linkage isomers are formed when the same ligand links to the metal through different atoms. Ambidentate ligands such as thiocyanate, nitrito, etc. give rise to linkage isomerism. You may see here the red compound which has a nitrito O, that is cobalt oxygen link, while the yellow isomer has a nitro, that is cobalt nitrogen link. Such compounds are called linkage isomers. Next, we may discuss coordination isomerism. Coordination isomerism involves switching the metals between cationic and anionic spheres. For example, here you can see coordination isomers where different complex ions are formed from the same molecular formula. In the first complex, cobalt is linked to ammonia and chromium is linked to cyanide ligands, while in the second complex, cobalt is linked to cyanide ions and chromium is linked to ammonia ligands. Next, let us see what ionization isomers are. If a ligand and a counter ion in a coordination compound exchange their places, then it results in ionization isomerism. These isomers exist as different ionic species in solution. For example, the former complex gives bromide ions and the latter complex gives chloride ions in solution. Now we will see solvate isomerism. This occurs when the solvent molecule is directly bonded to the metal ion or solely present as a free molecule in the crystal lattice. In fact, this is similar to ionization isomerism. Solvate isomerism results from the replacement of a coordinated solvent molecule, which in the case of water is called hydrate isomerism. For example, in the aqua complex of chromium, there exist 3 isomers with 3 different colors depending on the presence of water within and outside the coordination sphere. Next, we will see the different types of stereoisomerism, that is optical isomerism and geometrical isomerism. Complexes of type MABCD exist in 3 geometrical isomers. You can see that the ligand A can occupy the position trans to B, C or D. Octahedral complexes of formula MA4B2 is yet another example for cis-trans isomerism. Here, 2 ligands, say B, may be oriented either cis or trans to each other. Cis-trans isomerism is also possible if there is a bidentate ligand such as ethylene diamine. Here is an example of this kind. The complexes of the type MA3B3 can exist as facial and meridional isomers. In facial isomers, ligands occupy adjacent positions at the corners of an octahedral face, whereas in meridional isomers, ligands are positioned around the meridian of an octahedron. Finally, we may discuss optical isomerism. Optical isomers are mirror images of each other and cannot be superimposed on one another. These are also called enantiomers. As these cannot be superimposed, they are chiral too. They can rotate the plane polarized light towards the right or left based on which they can be dextro or levorotatory respectively. Here is an example of optical isomerism. Note here, only the cis isomer is optically active. I hope it is clear that isomerism in coordination complexes arises due to the structural differences between them. Have you ever thought why these molecules have same formula but different structures? These different structures result from the difference in bonding between atoms. We will discuss the theories related to bonding in coordination compounds in the next video. Now let's summarize what we have learned today.
Manorama Horizon. Learning made simple.